on the basis of origin. On the basis of origin, polymer is categorized into the three types. First is the natural polymer, second is the semi-synthetic polymer, and third is the synthetic polymer. The natural polymer. The polymers which are found in the plants and animals are known as a natural polymer. Some example of the natural polymer are protein, cotton, DNA, silk, cellulose, wool, and natural rubber. Second, semi-synthetic polymer. The polymer which are made by chemical treated with the natural polymer is known as semi-synthetic polymer. Some example of the semi-synthetic polymer is cellulose acetate, cellulose nitrate, cellulose acetate butyrate, nitrocellulose. Second is synthetic polymer. Synthetic polymer, the polymer which are synthesized by the low molecular compound formerly known as the monomer is called synthetic polymer. Some example of the synthetic polymer is a polyethylene, polypropylene, polyvinyl chloride, nylon, PET, PPT, polycarbonate, polystyrene, ABS, polybutadiene, silicon, rubber, and more on. Classification of polymer on the basis of molecular forces. The polymer is categorized into the four types on the basis of molecular forces. First is the fiber, second is elastomer, third is liquid resin, and fourth is plastics. Fiber. First is fiber. The polymer in which molecular chain are arranged in parallel to each other in spiral or helical pattern is known as the fiber. In fiber, L by D ratio is greater than or equal to 100. Second point, this polymer look like as a thread. Thread-like polymer. Their mechanical property is high. Some example of the fiber is polyester and nylon. These are typically used in the making of sport kit. You can see all the sport kit is made by either by nylon or polyester. Monomer, elastomer. In this polymer, structural units are arranged in the zigzag or helical form. They show the viscoelastic behavior. Viscoelastic behavior, that means when the polymer in the zigzag form, when apply the force, this zigzag form is tend to become the straight, and after removal of these forces it regain their original shape. So these polymers show viscoelastic behavior. The glass section temperature of elastomer is lower than room temperature. All the elastomer in amorphous nature. Amorphous nature. Some example of the elastomer. Example, this is silicon rubber, natural rubber, ethylene propylene diene monomer, EPDM, polybutadiene, liquid resin. The polymer which are found in the liquid form is known as liquid resin. Some example of the liquid resin is epoxy, resin. Second is polysulfide sealant and more. Epoxy resin also found in the liquid resin which is used as the adhesive. The plastic. The polymer which are the softened enough at the room temperature to molded into the desired shape and harden on the cooling, so they can retain the that shape is known as plastic. On the basis of the thermal behavior of the plastic, the plastic is categorized into the two types. One is the thermoplastic and second is the thermosetting. The thermoplastic, the plastic that are the softened and hardened reversibly on the changing the temperature. That means we change the temperature, the material, the property of the material does not change in the thermoplastic material, and each individual chain of the thermoplastic polymer are connected by the van der Waals forces. Some example of the thermoplastic are जैसे polypropylene, polyethylene, PVC, polystyrene, nylon, PET and more. Thermosetting plastic, the plastic that undergo some chemical changes on the heating and become individual mass is known as thermosetting polymer. The individual chain of the thermosetting polymer is interconnected by the cross-linking. So they become individual mass. Some example and make network, 3D network structure. Some example of thermosetting polymer are epoxy resin, phenol formaldehyde resin, UF resin, EMF resin, melamine formaldehyde resin. Classification of polymer on the basis of structure. The polymer are categorized into the three types on the basis of structure. First is A, linear polymer. Second is branch polymer. Third is 3D network या cross-link polymer. The linear polymer. In the linear polymer contain long and straight chain. They show highest degree of crystallinity among all these. The individual chain of linear polymer held by van der Waals forces. They show highest density due to their linear structure. Because of the linear chain, they compact to each other. तीसरा, classification of polymer on the basis of structure. The polymer is categorized into the three types on the basis of structure. The first is linear polymer, second is branch polymer, third is cross-link या 3D network polymer. First, linear polymer. Linear polymer contains long and straight chain. They show highest degree of the crystallinity. Individual chain of the linear polymer are held by van der Waals forces. The linear chain are closely packed, so the highest density. The example of linear polymer is SDP, polypropylene, PVC, polytetrafluoroethylene and more. Branch polymer. The branch polymer contain linear chain with branch edge. The property of the branch polymer is affected by the amount of branching. When increasing the amount of the branching, the flexibility and mobility of the chain will be reduced. That's why the glass transition temperature of that polymer is increases. So the many property of the polymer is affected by the amount of branching. Due to the branching, these polymers show less density compared to the linear polymer. Some example of branch polymer are जैसे LDPE, low density polyethylene is the branch polymer. VLDP is the branch polymer in which branch are short. Starch also come under the branch polymer and more on. 3D network polymer. This polymer form when the functionality of the monomer is greater than 2. If the functionality of the monomer is 2, then form the linear or branch polymer. But for the 3D network or cross link in the functionality of the monomer should be greater than 2. And individual chain of this polymer is held by the cross linking and form 3D network. That's why this polymer become infusible, and mostly 3D network polymers come under thermosetting. Thermosetting polymer comes under this category. Some example of this polymer is epoxy resin, phenol formaldehyde resin, urea formaldehyde resin, melamine formaldehyde resin, and more. The classification of polymer on the basis of tacticity. The polymer is categorized into the 3 types on the basis of tacticity. First is isotactic polymer, second is syndiotactic polymer, third is atactic polymer. In isotactic polymer, when the functional group या bulky side group arrange in the same side of the main polymeric backbone of a polymer, then that polymer is known as isotactic polymer. For example, isotactic PP. You can see the example. Isotactic PP. There is CH3, H, again CH3. You can see the bulky group CH3, same side of the main polymeric chain. This is the main backbone or main polymeric chain of the polymer, and this is the bulky group. You can see in this polymer the bulky group of the same side of the polymeric chain. So it comes under the isotactic polymer. In the syntactic polymer, the functional group or bulky side group are arranged in the alternative manner surrounding the main polymeric chain. For example, syntactic polypropylene. You can see here the bulky group. One bulky group here, then again here, then after one chain length is here and here. You can see this bulky group is arranged in the alternative manner surrounding the main polymeric chain. So it comes under the syntactic polymer. And atactic polymer, when the functional group or bulky side group arranged in the random manner surrounding the main polymeric chain या backbone of the polymer, so that polymer comes under the atactic polymer. Atactic polymer is nature in amorphous. For example, atactic PP. You can see this bulky group arranged in the random manner surrounding the main polymeric chain. One is here, again is here, then again is here. That you can see the no exact pattern of the CH3 attached to the main polymeric chain. So this polymer comes under the atatic polymer, and all atatic polymer in the amorphous in the nature. The classification of polymer on the basis of composition. The polymer is categorized into the two types on the basis of composition. First is homopolymer, second is copolymer. In homopolymer, that polymers come in this category which have the single types of monomer. In this example, the polyethylene. Polyethylene have the monomer ethylene. This single type of monomer. Polypropylene have the monomer is the propylene. PVC also come under the homopolymer, and the monomer of PVC is the vinyl chloride. Polystyrene is also come under the homopolymer, and monomer of the polystyrene is styrene. Polymethyl meth acrylate also come under the homopolymer because its monomer have the only single type, that is methyl meth acrylate, and more. The polymer in which two or more than two different types of monomer is used, that come under the copolymer. Copolymer is the further categorized into the four types. One is the alternate copolymer, random copolymer, block copolymer, and graft copolymer. This is the category of copolymer. Copolymer is the further classified into the four types. First is random copolymer, second is the alternate copolymer, third is block copolymer, fourth is graft copolymer. In the random copolymer, the monomer is arranged in the random pattern. Like the let A and B is the monomer of copolymer. So in that case of the random, they arrange in the random pattern. A, B, A, B, B, A, B, A, A, B. You can see there is no exact pattern, so this comes under the random copolymer. Some example of the random copolymer are nitrile rubber, SAN, styrene acrylonitrile, ABS, acrylonitrile butadiene styrene. This comes under the random copolymer. Alternate copolymer. In alternate copolymer, the monomer are arranged in the alternative nature. That means let A and B are the monomer of a copolymer. So in the alternate copolymer, they arrange in the alternate A, B, A, B, A, B. You can see here the monomer arranged in the alternate, the A, then B, then A, then B, then A, B. So this comes under the alternate copolymer. Some example of the alternate copolymer are styrene maleic anhydride, L-1 6. L-1 6 is also comes under the copolymer, in which two types of monomer are used. In a block copolymer, monomer arranged in the block. That means when A and B are the monomer of a polymer, then monomer arranged in block, then A. You can see the block of monomer A, then B. You can see here is the block of monomer B, then A. You can see here the block of monomer A. So these polymers comes under the block copolymer. Some example of the block copolymer are styrene butadiene styrene, polystyrene block, polymethyl methacrylate. These polymers comes under the block copolymer. In graft copolymer, the main polymer chain contain one types of monomer and branch contain other types of monomer. For better understand, let A and B is the monomer of the graft copolymer. So the main polymeric chain contain only one types of monomer, that means only A. And branch contain one types of monomer. You can see here the main polymeric chain contain only A monomer and branch contain only B. So this polymer comes under the graft copolymer. Some example of graft copolymer are HIPS, high impact polystyrene, the polyethylene oxide acrylate. These polymer also come under the graft copolymer. Biodegradable polymer. 6 is biodegradable polymer. The biodegradable polymer, that polymer which degrade in the environment due to the hydrolysis, oxidation process. Some example of the biodegradable polymer are the first is polyhydroxybutyrate (PHB), polylactic acid (PLA), and polyhydroxyalkanoates and polysaccharide. This comes under the biodegradable polymer. Conductive polymer. The polymer which conduct electricity is known as the conductive polymer. Some example of the conductive polymer, first is the acetylene. Acetylene is an example of the conductive polymer. We can see there is the double bond in their repeat unit, and this is the responsible for the carrier of charge. Second is the polypyrrole. Polypyrrole is also come under the conductive polymer. You can see here this pi bond and lone pair of the electron is the play the role of the carrier for the charge. Second is the polythiophene. Polythiophene also come under the conductive polymer. Same cases, this double bond and the lone pair of the sulfur which is used to the responsible for the carrier of the charges. And polyphenylbenzene. This polymer also comes under the conductive polymer. Both double bond and the lone pair of the oxygen used do the resonance, and that's why it helps as the carrier, use as the carrier of the charge and help the flow of the electricity. Polyphenylene. We can see the resonance in the benzene ring, which is the responsible for the carrier of charge. Polyethylene. Polyethylene, same case, the double bond and the benzene ring do the resonance with the lone pair of the nitrogen and use as complete the resonance cycle. That's why play the role of the carrier of the charges. That's why electricity is easily flow.